All right, Mr. Antonucci here, and this is our third and last video for this section. In this one, we want to construct and interpret a two-sample t-interval for a difference in population means. So this is called a two-sample t-interval for a difference in means, and this is a confidence interval used to estimate a difference in means of two populations or treatments with unknown standard deviations. So we have an example here um, in a study published in the American Journal of Clinical Nutrition. Researchers wanted to know if changing food portion sizes would influence subjects' food consumption one day later. The volunteer subjects were randomly assigned to two groups. There's the random assignment, with one group being served small portions of food and the other group being served large portions of food. On the next day, all of the subjects were allowed to serve themselves, and researchers recorded how much food they consumed. Here's a summary of the results. So we don't have the raw data, but we do have the summary statistics, including sample size, sample mean, sample standard deviation. And we want to construct and interpret a 95% confidence interval for the difference in mean amount of food that would be consumed the next day by people like the ones in this study who were given large portions and those who were given small portions. So we're going to do the four-step process here. As always, we have to do all four steps. The first thing we're going to do is state. Um, so we want to construct a 95% confidence interval for the difference of means. You have to indicate the subtraction, the direction of subtraction here, so large minus small, and define the parameters of interest in the full context. So it's going to take a little writing or typing, but the mean of the large portion is equal to the true mean, represents the true mean amount of food that would be consumed grams the next day by people like the ones in the study who were given a large portion. And then mu small is same thing, but for small portions. Okay. Um, the next step, state plan. We want to plan and carry out a two-sample t-interval for the difference in means. So we're going to check the conditions now, but before we do, we want to make sure that we say what procedure we're going to check the conditions for. So random sample, or the random condition rather, volunteers were randomly assigned to receive large portions or small portions of food. So that one is satisfied. The 10% condition is not appropriate to check here because the experiment used volunteer subjects. So they're not real random sampling. This is random assignment of treatments. So then we can just skip to the normal large sample condition, and both samples were above 30. So we're good there. We don't have to produce a graph. All right. In the do step, we're going to calculate the mean difference plus or minus the t-star critical value times the standard error of the difference. And again, you would get that formula from the formula sheet, not this full formula. You have to remember how to set this up, but the formula for the standard error is going to be on the formula sheet for the AP exam. Then using technology, we get a confidence interval of 15.57 to 74.93. And it's important that you also list the degrees of freedom for that one there, and all of these whenever you're doing them. And then finally, we're going to write our conclusion. We are 95% confident that the interval from 15.57 grams to 74.93 grams captures the true difference, indicate the directions, large minus small, in the mean amount of food that would be consumed the next day by all people, like ones in this study who are given large portions and those who are given small portions. All right, there's our full construction of a confidence interval. We stated what we were going to do, define the parameters of interest, check the conditions after we stated which procedure we're going to use, showed some work to calculate the confidence interval, and then made our conclusion. Now we can get some additional information from this confidence interval because this interval does not include zero, which is interesting because this gives us convincing evidence that the difference in the true mean amount of food that would be consumed the next day by people like the ones in this study who are given large portions and those who are given small portions isn't zero. Okay, so there is a distinction. However, the confidence interval is going to provide more information than a simple reject or fail to reject the null conclusion because it gives us a range or a set of plausible values for the true mean difference of the population here. All right, guys, that's it for this one. Hope that was helpful. Reach out if you have any questions and take care.